It's the general equation of a line, which is y equals mx plus b. I want to give one more example of a relationship that a line can represent. So let's say in this case the x-axis is the number of minutes that you ride a taxi, and the y-axis is the cost depending on the minutes. So let's say the taxi driver has an initial fee. So no matter how long you ride the taxi, you're going to pay at least $1. So the initial fee of just getting into the taxi is $1. And then per minute, let's say the taxi driver, per minute, or let's change this to, actually, yeah, per minute works. So let's go with per minute, the taxi driver charges you $2. So it's a very, very expensive taxi. So let's see what let's see if we can graph this visually. So the initial cost is $1. So that means at 0 minutes we're at $1. So before we go ahead and graph it, let's label our x-axis and y-axis a little bit. So let's go with these are the number of minutes. So we're gonna go with 1, 2, 3, 4, 5, 6, and so on. And let's label the y-axis. Let's go with 1, 2, 3, 4, 5, 6, and so on. So now let's think about what's going on here. So no matter how long you ride the taxi, so if you let's say you ride the taxi for 0 minutes, you're going to pay the initial fee of $1. So at 0 minutes, you're going to pay the taxi driver $1. So let's label that point. So you're already paying $1 at 0 minutes. Now, per minute, you get charged an extra $2. So at 1 minute, you're gonna be paying the initial fee already and another $2 because it costs $2 per minute. So at 1 minute, you're paying the initial fee of $1 and you're paying $2 for the minute that you spent. So you're paying a total of $3. So let's label that. So at 1 minute we're paying $3. So 1 minute we go up $3. That's our next point. And you might see that you might already see the pattern that as we keep going, this is gonna be a line that we're gonna be able to connect. So let's do a couple more points. So let's say you ride the taxi for 3 minutes. So actually, let's say you ride it for 2 minutes. Okay, so for 2 minutes, once again you're paying the initial fee. So at 2 minutes, you're paying the initial fee, which is $1. So that's always going to be there, $1. You're also paying for 2 minutes. So if it's $2 per minute and you're going for 2 minutes, then you're paying $4. So we have $4. Now in this case, the total is going to be, well, 1 plus 4. So total is $5. So let's go ahead and label this. So we're at 2 minutes, we're paying $5. So once again, very expensive taxi. So 2 minutes, $5. It's around right there. So now we have now we can connect these points and visually represent our line. So let's go ahead and do that. Let's go ahead and connect these points. Okay. So in this case, negative minutes doesn't make sense, so I shouldn't have drew it here, but just for sake of a linear representation, we're just going to go with it. So this line represents the minutes, or the cost, depending on the minutes. And now you can calculate your cost at 6 minutes by just drawing the line out until you get to 6 and just extending this and being able to calculate your cost depending on the linear equation. And what we can do here is represent this with an algebraic equation, and we can use the general equation y equals mx plus b. And as you already might have an idea of how to do that, If not, it's okay. We're going to go over it in this video. So let's say we have, so let's start with the general equation y equals mx plus b. So we're still going to use our taxi analogy. So the first thing is we know that at 0, so x is our minutes. So this right here is a relationship represented by two variables. So x in this case is our minutes, and y is our cost. So x and y can represent, you know, anything, but in this case x and y are minutes versus costs. So, and our b value is our y-intercept. In other words, our initial, in this case, initial cost. And then our m is our slope, which in this case is our per minute cost. So in this case it's $2. So now we can represent this in this context with an equation that can represent the algebraically. So we have y equals our slope, which is $2, times x. We can plug in any x value, we're just going to leave it as x, plus b, which is our initial cost, so plus 1. And this right here is a linear equation. So in the next video, we're going to be practicing on how to derive linear equations from graphs and from points.